Hello everybody and welcome to a new Open Class. We are today hosting Open Class number 199. So we are just one Open Class away from reaching the 200 mark, where we are going to prepare something special for sure. But for today's Open Class, we are going to be diving into some AI. We are going to be more specifically exploring the decision theory, the Bayesian decision theory. We are going to we are going to do some very basic examples first, and then we are going to apply it to some more complex scenario. I hope you like it. So yeah, let's already get started. Let me know, as always, please, there in the chat if everything is fine, if sound is fine, you can hear me properly, if the video is fine and everything, so that we can get started without any problem. Then, meanwhile, I'm going to start switching my screen already to the to share my computer screen. There we go. So I'm going to log in here myself to the Open Class page so that I can have the chat here available. Let me go there. There we go. All right, so I can see here everybody: Khaled, Natalie, Desire, Gilbert, Habib, Marius, Alberto. All right, so hello everybody. Perfect, all fine for me. All right, then that means that we are ready to get started with the class. Then, as always, the very first thing that we need to do in order to properly start with the class is to get the associated project for today's class. Then that is very simple. All you have to do is to click on this button that you are going to find here right above the chat box here. This button which says fork and open the class project. All right. And I'm going to click here myself also, because I also want to have the project for today's class opened. There we go. Then as soon as you click on this button, you are going to be redirected here. As you can see in my case, this is the main project page. All right, and here you are going to have the in the right side, you are going to have the streaming panel with the video, the chat, and everything. You can leave it here. You can move it to a new window, whatever you want. In my case, I'm going to remove it from here and move it to a new window right here, because I want to have more space in my project page. So I'm going to leave it here so that I still can have access to the chat and see your comments and everything that you say. There we go. And then this is the main project page, which should finish loading after a few seconds. Okay, here you can see in my case it has finished loading. Let me close all these things. Then, as you can see here, my terminal window has automatically opened and it is installing some things, okay? This is expected because we need to install some dependencies in this project for it to work properly. Then it is very likely that in your case, when your project page loads, you are going to also see this, okay? Your terminal window is going to automatically open, and then you're going to see that some log messages here indicating that it is installing some things, all right? In case this does not automatically open for you, what you can do is to just click manually here in the terminal button, which is here in the bottom menu. Yeah, you have this button, which is the first one. Yeah, if you click here, this is going to open your terminal, and then the installation process is going to automatically get started. All right. Then, first thing is to install the requirements, and second thing is that you are going to be able to see the class notebook right here. Yeah, the notebook for today's class. As you can see, Open Class number 199. And AI Foundations for Robotics. So this is the project that we are going to be using for today's class. Yeah? Then this is the first step. Now, meanwhile, the projects get loaded, let me tell you that besides this project for today's class, you are going to also have a copy of this same project in your account. Yeah. How to reach it? Very easy. You can come here to the main construct page, and then in the left menu you can navigate to the My Projects section, as you can see right here. I'm going to open it here, and then you are going to find a copy of this project here in your account. Yeah, and you are going to have access to this project basically for forever. Yeah, so in case that you want to open this project again next week, next month, whenever you want, you are going to be able to do so. All right, not only for today, for today's class, but this project is yours already forever. Okay, then yeah. So let me know, please, if you everybody has been able to properly open the project with the notebook, and everybody has been able to install the dependencies here in the terminal. Yeah. Again, in case your terminal didn't open automatically, don't worry. All you have to do is to open the terminal manually by clicking here in the web shell button. Yeah, if you click here, then your terminal is going to open and the installation process is going to start automatically. So let me have a quick look here at the chat. All good. Terminal didn't open. All sorted now. Install it. Yes, not yet. Okay. All sorted here too. Awesome. All right. Okay. Then I guess that we are ready to get started. Okay. Then the class of today is named AI Foundations for Robotics. But more in particular, we are going to be talking about decision theory. Okay, we are going to go to get there in a moment, and we are going to introduce the concept of Bayesian decision theory on a very, very basic state, all right? Because AI, decision theory, actually any topic related to AI is very complex, and it cannot be taught properly in a class in 1 hour, all right? But we are going to get a very basic introduction into the concept of Bayesian decision theory. And then we will see a practical example with the robot also. But I want to start by saying that this class is based on the AI Foundations for Robotics course, which you can find a link here, all right? This course is the one which is going to which goes much more in depth over all these foundational concepts related to AI. Yeah. So let me click here to open the course. You can go directly to the course page by clicking here in the image. Yeah. This is the AI Foundations for Robotics, which is a new course that we have added to our platform. And this course is going to stay at the very, very core foundation concept related to AI. Yeah. So all of us are used to AI tools such as ChatGPT or other kind of more advanced stuff, yeah. But on the very, very, very basic level, AI is mostly based on mathematics, on concepts such as statistics, probability, yeah. So all these core concepts are the ones that you are going to explore and you are going to learn about in this course. So you can see it has several units. You are going to cover from univariate probability through multivariate model, statistics, decision theory, which is the unit in which I have based today's class, information theory, logistic regression. So all of this is, it has a lot of maths involved, yeah? But if you really want to know how AI works, you need to know about all these topics, yeah? So these are the very, very core foundations of more complex AI models, all right? Then there are many things involved here. In today's class, of course, I'm going to be skipping many parts, okay? So sorry about that. Also, I am not a big expert on AI, so I had to study a little bit about this topic in order to prepare for today's class. But the concept that we are going to cover is Bayesian decision theory, okay, which is also a very foundational concept related to decision making, yeah, which is a behavior very strongly related to AI, to artificial intelligence, yeah, the ability to make decisions, that the robot makes decisions on its own. All right. So before getting started, let me quickly have a look here in progress. There is echo, says Donato. Okay, sorry for that. I don't know why. Maybe I'll try to move a little bit far away from the mic, and let's see if that makes it a little bit better. All right. Then the next thing I want to do is to get started with the simulation. Okay, we are going to be using a very cool simulation for today's class, for the last part actually of today's class. Then in order to start today's simulation, you have the command here, all right? So right below the link to the AI Foundations for Robotics course, which I have just talked about, you have the start the simulation section, okay? Then in order to start the simulation, all you have to do is to copy and paste this command that you have here, yeah? You can copy directly here from the notebook and then paste it here into the terminal, all right? This is an SHS script, which is going to automatically start the simulation. So copy it from the notebook directly, paste it into your terminal, and then press enter to execute it, okay? You are going to start seeing here many log messages, yeah? And again, after some seconds, the simulation window should automatically pop up here in the project page, okay? So let me wait myself here for some seconds. And see if the simulation automatically appears, okay? In case it doesn't appear, do not worry, all right? In case it doesn't appear, don't worry, because we can also open the simulation window manually, all right? So here, for instance, some seconds have already passed. So in case your simulation doesn't appear automatically, which is my case, for instance, it's not appearing here, all you have to do is to open the simulation window manually, all right? Then for that, it's very easy. Again, you go to the bottom menu here in your project page, and then the second, no, not the second, sorry. The fourth icon here, it says Open Gazebo, as you can see, all right? Then here, if you click in this cube icon, which is the simulation button, the gazebo button, this is going to, as you can see, open the gazebo window. And then here you should be able to see the simulation, all right? Let me wait here a few moments. Simulation should appear. Okay, so for some reason it's not appearing. Then what I'm going to do is to restart the simulation, okay? Probably for you, the simulation has appeared already. In my case, it's not appearing for some reason, so let me just restart the simulation. Sometimes Gazebo works so-so. It has some strange errors. So let me just restart the simulation, execute again the command, like this, and hopefully this is going to solve the issue. Let's see. Not appearing yet. Okay, let me wait for some seconds. What about you guys? Has the simulation loaded for you? No echo here. It disappeared. Okay, great. Gazebo playing up with me too. Okay, Alberto says yes. Also, Alan got it loaded. Steven is passing here a warning message. Do not worry about these warnings. Not important, Steven. Simulation running, worked. It's a period, restarted, struggling. Okay, so for some people it's loaded, for some others don't. Okay, for me it has just loaded. Okay, see? So in case it doesn't load, try to do same as I did, which is to stop the simulation command here with Control-C, and then just execute the command again. Okay, that should solve the issue. Okay, like for me. Then, as you can see, here, my simulation has loaded, and this is a spaceship environment, which is the recreating the axiom. Yeah, we have several rooms here, and the main area of interest for today's class is this room here. Yeah, you can move around the environment, all right, with your mouse. You can zoom in, zoom out, etc. So let's come here to this room, which is the recycling center, as you can see. Yeah. Then inside here, you are going to find the AI bot, which is this tiny guy that we have here, and then we have some objects in front of him. Yeah. We are going to see in a moment what all this is. Okay. But for now, let's just make sure that we launch the simulation and that we put the focus of the simulation, yeah, we move the camera so that we are in this recycling center, okay? Which is the area of interest for today's class. Yep. Is it clear? Finally loaded, says Ahmad. All right, great. For the others, have you been able to load the simulation, guys? Desire says loaded also. Awesome. Also Win. Also Donato. Also Arkham. Okay, awesome. Then we are ready to continue. Okay, excellent. So with the simulation being loaded, let's jump straight into the concept, the main concept of this class, which is the Bayesian decision theory. Okay? Then what is the Bayesian decision theory? Basically, this is a mathematical framework for making optimal decisions based on probability and available information. Okay? In the case of the AI robot, which is this robot that we have here inside the recycling center, in the case of our AI robot, it provides the Bayesian decision theory, it provides a formal framework for making optimal decisions about where and when to clean. Okay, this is an example. Considering uncertainty and associated costs. Yeah? Okay, so our AI bot, yeah, it is intelligent and it is able to make several decisions. Yeah? Then let us say that it is making decisions about one particular room. It has a set of possible actions, which are represented by the A symbol, to choose from. For instance, it can decide whether to clean a room or not. Okay? This is an example. Okay? I am introducing here an example scenario. Okay? So let's imagine that our robot is navigating through this spaceship, and then, as you can see, there are several rooms here. So in some of them there is dirt, as you can see here. Some of them are already clean. Yeah. So the robot has to navigate over all this spaceship, navigate through the different rooms, and decide if it's going to clean the room or not. Okay. This is the introductory scenario that we are getting presented here. Yeah. Then the possible actions in this case are whether to clean the room or not. And then there is also a set of states that the room can have, which are defined with this H symbol, which basically are if the room is dirty or not, right? So two possible actions, whether to clean the room or not, and two possible states, whether the room is dirty or it is not dirty. Yeah? Then each of these actions has associated costs and benefits that depend on the state of the room. Yeah? For example, if the room is clean and the robot decides to clean it, it is going to use a lot of resources, such as energy and time. On the other hand, if the room is dirty and the robot decides not to clean it, then the cost is also very high because the robot is basically failing to do its duty, which is to clean the rooms, right? Then we will represent the different states of the room with H and its actions as A, as I have introduced it right now. Then, in general, we will say that each combination of a pair action state has an associated loss. The different combinations of our robot possibilities can be encoded in a matrix like the following. Yeah, so here we have the state action. Yeah, so the state can be dirty or clean. Yeah, these are the two possible states of the room. And the actions are not cleaning the room or cleaning the room. Then, if the room is dirty and the robot decides not to clean the room, this is going to have a very high loss. Yeah? On the other side, if the room is dirty and the robot decides to clean it, then it's going to have a very low loss, or what is the same, a very high benefit, right? And with respect to the other state, if the room is clean and the robot decides not to clean the room, then this is also going to have a low loss and a high benefit. Whereas if the room is clean and the robot decides to clean the room, this is going to also have a high loss. Okay, so this is the matrix which associates loss with states and actions. Okay, you can see this represented in a more graphical way in this image here. Yeah, so we have our robot here and the room states. Yeah, so if the room is dirty and the robot decides to clean the room, this is going to have a low loss associated. Yeah, if the room is clean and the robot decides to clean it, this is going to have a high loss. Why? Because we are wasting resources. Yeah, if the room is already clean, we don't need to clean it again. Yeah, we are wasting resources. Therefore, we are going to have a high loss here. Okay? Then, if the room is dirty and the robot decides not to clean the room, also this is going to have a high loss because the purpose of the robot is to clean the rooms. So, in this case, it is not fulfilling its purpose. So, this is going to have also a very high loss. Yeah? And if the robot is, if the room is clean and the robot decides not to clean, then this is going to have a low loss. All right? Of course, all these losses are arbitrary, okay? We can decide them. Yeah, we are going to see now some examples of this. Yeah? Then, in general, all decision theory problems can be faced in the same way we have done. Yeah, this is a very simple example, a very simple principle, but this can be applied to almost anything, okay? This is the basic principle in which much more complex decision-making is based, yeah? So we assume that the decision maker or agent has a set of possible actions, A, to choose from. At the same time, nature or the world has a set of possible states, H, yeah? And then we can encode information about costs and benefits into a loss function, which specifies the loss associated with taking action when the state of nature is H. Yeah? So far, so good. Does this make sense? Yeah? Still loading, installing packages, blah, blah. Okay, John. Don't worry. Probably you are going to catch up. Cannot maximize the gazebo tab for some reason. Okay. Well, to maximize the gazebo tab, all you have to do is to click here in the double arrows here. This should maximize the gazebo tab. Okay. Yeah, so yeah, so far so good. All right. Then let's continue with our basic example. Yeah. So we are going to create a practical example here. Yeah. Let's say that we want to help our AI robot to take a decision. Yeah. Then to do that, we are going to define a loss function. Yeah, we are going to define the loss function. Yeah? Then let's assume the following notation. Yeah? So we will say that the set of actions that the robot can take are C and C dot, let's say. Okay, I don't know how to call this symbol. Yeah, C and C minus or whatever. Okay, C and C minus. Yeah, where C minus means that the robot does not clean the room, and C means that the robot cleans the room. Yeah, and also on the other hand, we will say that there are two possible states, D and D minus, where D minus means that the room is clean and D means that the room is dirty. Yeah? Then we can define the following loss function. Yeah? DC minus has a loss associated of 100. DC has an associated loss of minus 50. Whereas D minus C minus has an associated loss of 0, and D minus C has an associated loss of 10. Yeah? What does this mean? This means that D, so the room is dirty, C minus, the robot does not clean the room. Yeah? So if the room is dirty and the robot does not clean the room, this is going to have a very high loss, 100. Yeah? On the other hand, if the room is dirty, but the robot cleans the room, this is going to have a negative loss, which basically means benefit. Okay, sorry for this. Let me go back here. Yeah? Very high loss, very low loss, which effectively it's a high benefit. Yeah? And here we have the state where the room is clean. So if the room is clean and the robot does not clean the room, this is going to have a 0 loss, yeah? So not positive and not negative. And if the room is clean and the robot cleans the room, this is going to have a low loss, okay? What does this mean? This means that we are penalizing much more the robot for not cleaning a room when it is dirty than for cleaning a room which it is already clean. Yeah? Do you see this arbitrary decision? Yeah? So we are taking the decision to assign a higher loss for the robot not cleaning a dirty room than for the robot cleaning a room which is already cleaned. Yeah? Why? Well, because we don't mind so much about the robot cleaning a room which is already clean. Yeah? Yes, okay, it's going to waste some resources, yeah? But we prefer that than the robot not cleaning a room which is dirty. Yeah? Do you see the key difference here? Yeah? How we are putting these arbitrary values in the loss function in order to drive the robot to prefer one decision than another. Yeah? Yeah, so this is arbitrary, AMNA, okay? These values are arbitrary. Yeah? In fact, I encourage you later to try playing with these values. Okay, now we are going to put this into a code and we are going to see all this. Okay, then besides these loss functions, this loss function that we have designed here, then we have a couple of probabilities as well. Yeah, so according to our analysis, yeah, previous data that we have recollected from the spaceship, yeah, we found that the probability of the room being in D state, which is, let me remember, dirty, yeah, the probability of the room being dirty is 40% or 0.4. Whereas the probability of the room being clean is 60% or 0.6, right? So with this, we are going to create a Python script in order to demonstrate this, okay? Then let's right now open a second terminal here. Let's go to our web shell, to our terminal. Yeah, don't close this one because here is where we have our simulation running that we are going to be using later, yeah? Instead, let's open a second terminal by clicking on this @ icon here, yeah? If you click here, this is going to open a brand new terminal here that you can use now for whatever you want. Yeah? Then here we are going to execute the following commands in order to create this Python script. So we are going to navigate inside the ROS to workspace src folder. We are going to create this decision folder, right? Then we are going to go inside this decision folder. Inside here, we are going to create a Python script named like this, simple action decision.py, and then we are going to also provide execution permissions to this script. Yeah? So now we are inside this decision folder and we have created our Python script. Yeah? So next step is to add the following code into our script. Okay, then for this we are going to use the code editor because it's much more convenient. So let's go to the bottom menu in our project and open the code editor, which is the second button here, code editor, as you can see. If you click here, this is going to open the code editor, which is going to allow you to basically navigate through the folders and files of this project with a graphical interface, which is always much more user-friendly, right? Then we can go inside the ROS to workspace src. You are going to find several packages here related to the simulation and so on. Don't worry. Let's go to the decision folder, which is the one that we have just created now. Decision folder. And here we are going to find the simple action decision.py script, yeah, which right now it is empty. Yes, because we have just created this script, so it is empty. Then what we need to do is to copy the code here from the notebook, copy the code from the notebook, and paste it here into the file with the code editor, like this. And then we save, okay? Right? Okay. Then, before executing this code, let's have a quick look at what we are doing here. Well, first of all, we are defining here our loss function. Yeah? This is the loss function that we have just reviewed here. Yeah? So we define our loss function here. We define the probabilities. And then we compute the expected loss for each action by iterating upon the room's possible states and storing it in the expected loss dictionary. Yeah? Then in this dictionary, as you know, a dictionary is a pair of key value. Yes? Then in this dictionary, the keys are the possible actions and the values are the expected losses. Yeah? So let's execute here our code and let's see what we get. Yeah? In order to execute the code, you have the command here, Python 3, and then the name of the Python script. So again, you can copy and paste directly here from the notebook and paste it to the terminal. So what are we going to have here? Well, we have that the C, yeah, which is, let me remind it here, C, which means that the robot is going to clean the room, has a loss of minus 0.14, whereas a C minus, which means that the robot does not clean the room, has a loss of 40. Yeah? So the robot, the decision that the robot is going to make based on our data is to clean the room. Okay, this is the most likely decision that the robot should make in order to get the lowest loss or the highest benefit. Okay, based on our loss function and based on the room probabilities. Yes? So let's say that the robot doesn't know anything, then the most likely decision to take would be to clean the room based on this data. Right? So here already we are providing our robot with some decision-making capabilities. Okay? Based on this basic principle of Bayesian decision theory. Okay? Yeah? So, as we work with the expected loss, we want the action that minimizes the loss. Yeah? So based on our loss function and the probabilities of the room's different states, the bot should perform the action C, cleaning the room. Okay? Now here you can play with the values. Somebody was commenting that he was expecting to have the same loss here and here. No, sorry, here and here, which are both positive actions in theory. Yeah? So playing with this is going to change the outcome. Okay? As somebody mentioned here. As Amna was mentioning. And in fact, we are going to see this right now, okay? Here, AI is showing an error. Yeah, so probably AI, Jones, if you are getting an error, probably it is because you did something wrong when copy-pasting the code, okay? So try to remove your code here. And sometimes when you copy it with this tool, it introduces some strange characters, okay? Let me see if it happens to me. See, now, this, if you have these characters, this is not good, okay? Because it's going to introduce some errors. Sometimes this happens, yeah? So if you have this, just remove all the code and copy it directly like this, okay? Select the code, copy it like this, and then paste it into the code editor, right? That should fix the problem, okay? Yeah, exactly. So copying with the tool, sometimes this is a book in the system. Sometimes it introduces these strange characters. So just select the code directly like this, yeah, and copy and paste. That is going to work. All right, then let's change the scenario, right? So let's say that our Axiom spaceship, it is in an emergency state because it has very low energy supplies. Yeah? So our spaceship, our Axiom spaceship, right now it's entering in emergency mode because it has a very low energy supply. What does this mean? This means that we want our robot to maximize, to optimize as much as possible its energy resources, yeah? Then in order to follow this new emergency situation, what we are going to do? Well, we are going to change the loss function, yeah? How? In this way, yeah? So, okay, let me, because I don't remember the states, so let me copy this and put it here to see the new... Let me put it here. Yeah, so these are the new states. Well, actually, let me put it here. There you go. Okay? So this is the new loss function. Yeah? Based on our new emergency state. So, if the room is dirty and the robot does not clean the room, this is going to have a penalty of 10 now, yeah? Instead of 100. Yeah, so we are lowering the loss, the penalty for this action, yeah? For the robot not cleaning a dirty room, yeah? For DC, which means that the room is dirty and the robot cleans the room, we have a very low loss, which means a high benefit. This is the same as before. This state is the same as before. And this state, which is that the room is clean and the robot cleans the room, yeah, for this action, we are increasing 10 times the loss. Why? Because in this action, we are cleaning a room. Let me change my keyboard here, sorry. Yeah. In this action, what we are doing is to clean a room which is already clean, meaning that we are wasting energy from the robot, yeah? And what happens? That now our spaceship Axiom, it is in an emergency state because it has very low energy supplies, yeah? So now we want to penalize a lot this action because it is wasting resources, yeah? Therefore, what we do is to update our loss matrix, like this, yeah? Then what happens if we update our loss matrix like this? Let's see what happens. Let's update our code. So let me copy this code now and update it here in the script. And now what is going to happen if we execute again our program? Let's see. So if we execute again our program, we have something different, yeah? Now, this action has a much higher penalty than this one, yeah? So by changing the loss matrix, we are changing the decision-making of the robot, yeah? So in this case, our AI bot is going to perform the preferred action for our bot, for our cleaning robot, is to not clean the room because it wants to save resources. Yeah? So, what can we get from here? That the loss function plays a crucial role in decision making. Okay? Yeah? Now, this is a very basic concept, okay? But yeah, this idea can be applied to much more complex decision-making situations. Okay, these are the very basic principles. Yeah, which is this Bayesian decision theory, which, by the way, it has many more things to it. Okay, here I am staying very much in the surface of it, but I cannot deep dive. Okay. Because that would require a lot of time. But all these details of more complex situations and everything, you are going to find them in this course, okay? In the AI Foundations for Robotics course, okay? Now, here, I want to play with an example, which is a bit more complex, but still uses this principle of Bayesian decision theory, okay? So let's go with the following example, where we are going to be interacting now with the simulation, okay? Then now, in this example, in this final example, what we are going to do is to help our AI robot to classify objects, okay? Then, for this, we are going to use an action, okay, like this, which is deposit trash. Yeah, this is the definition of our action, deposit trash, which has a goal. The goal is an object type, which can be of 4 different objects: metal, plastic, organics, and woolly, which is these trash cubes. Yeah. So as you can see, we have 4 different objects or materials, which are metal, that are represented by this lamp here; plastic, which is represented by this ball; organic, which is represented by this tree inside the shoe; and finally, woolly, which is represented by these characteristic trash cups that woolly generates. Okay? Yeah? Then, our robot, with some predefined training that we have provided to it, should be able to classify objects based on these 4 materials. Okay? Then, for this, we are going to use a predefined action server, where we basically specify an object type, which is one of these 4 different types or materials, and then the robot should autonomously go to the specified one. For instance, if we specify as goal plastic, the robot should automatically go to the plastic bin here. Yeah? The plastic container. Yeah? Then, in order to launch this action server, we can run this command. So let me copy the command here from the notebook and start the action server here in the second terminal. And then I'm still going to need a third terminal here for the client, okay, which we are going to run in a moment. Yeah. Then the code for the client, you can find it here. Yeah, here you have the path. ROS to workspace SRC, classify trash action client, classify trash action client.py. Yeah. Let me navigate to this file using the code editor. Yeah. So ROS to workspace SRC, classify trash action client. Here it is. Again, classify trash action client, and then here action client.py. Yeah. This is the action client code that we are going to use to send goals to this action server. Yeah. Then let's very quickly have a quick look at this code. Yeah. So first of all, we have the action client, which, as you can see, it depends on the node ROS class. Yeah. So this is a ROS to node. Okay. Then we are creating our action client here, which is connecting to the deposit trash action server. And then the key part here is this send goal method. Okay? Yeah. Here what we are doing is to get the material, and then we are simulating sensor responses. Okay? We have a class here. By the way, if you want to have a look at this class, for instance, simulate sensors, you can open the custom libraries code here and dive into this code. Okay? I'm not going to get inside this because it's too complex for this class. But in case that you want to investigate a little bit more on your own, you have all the code here. Okay? Here. Yeah, so somewhere here we have the sensor class and the simulate sensor method and everything. You have all these here, right? Yeah, simulate response. Here you have it. All right? Then we simulate what would be a sensor response based on the material. Yeah. So if the material is plastic, if the material is metal, if it's organic, etc. Yeah. And then based on this data, yeah, and the probabilities of the items, which are defined, also are predefined, we are going to take a decision using this make decision method, which you can also find inside here. Yeah. Let me show it to you. Make decision. Okay. Now, this make decision method is a bit more complex because it has other variables into account, but basically it is based also in the Bayesian decision theory framework that we have just introduced here on a very basic level. All right? Yeah? Let me come here. All right. And then based on that, the robot is going to take a decision to move to one object or another, and then it's going to send the goal to the action server in order to effectively move to the corresponding container. Okay? So let's see an example of this decision making. Then for this, what we are going to do, let me go back here to the notebook. Yeah, here you have also the code explanations and everything. By the way, also I forgot about the main function, which we have also down here. Let me show it quickly to you. Here in the main function, as you can see, we are defining the materials, plastic, metal, organics, and woolly. And yeah, here we have some values, probabilities for the sensors, camera, durometer, and densimeter. Yeah, these are the sensors that we are defining for our AI robot, that we are simulating for our AI robot. And also very interesting, we have here the loss matrix associated to each material. Yeah. So what does this mean? That if the material is metal and the robot decides that it's metal, we are going to have a 0 penalty in the loss function. Yeah. For instance, if the material is metal and the robot decides that it's plastic, we are assigning a penalty of 10 in the loss matrix. Yeah. And on the other side, if the material is metal, but the robot decides that it is Wally, yeah, these trash cubes, remember, Wally is trash cubes, then here we are assigning a much higher penalty, for instance. Yeah? So this is the loss matrix assigned to provide penalties and benefits to the decisions that the robot makes. Okay? Also, later you can play with this loss matrix and see how it affects the robot decision making. Okay? But now let me run the example very quickly here. And in order to run the example, we have to run the client like this. Yeah, here we have the command to run the action client. Yeah, how does it work? So we have the action server running here, and in the third terminal we are going to run the action client. Yeah, and then the action client is going to ask us to insert one material to classify. Yeah, from the following four: metal, plastic, organics, and Wally. Yeah. So for instance, let me start by trying metal. Yeah. So if our robot does the correct decision, it should go to the metal container, which is this one in the left, as you can see. Yeah. This is the metal container. So let's type here metal, enter, and let's see what the robot does. So we can see that the robot starts navigating here towards the, metal container. Yeah. So it has done the correct decision making. It's going to go back. Yeah. And I can keep testing with the other materials. For instance, let's try now plastic. Yeah. We can see that the robot is going to move to the plastic container, which is this one here. There we go. Let's also try now Wally, which is this one here. Let me try Wall E here. Yeah, so we can see the robot going to the Wall E container. Excellent. And the final one is organic, right? It was, if I'm not wrong, organics. Okay. So let me try with organics as well here. Organics. There we go. All right. So this is an example or a classification example, yeah, which is a bit more complex of what I have explained in today's class, but still it follows the same principle, and it's based on this same principle, adding some additional layers, okay? Unfortunately, for today's class, we don't have time over all this. There are many, many things involved in here. You also should learn a little bit first about probability statistics in order to properly understand all the intrinsics of this decision making. Yeah, but I think it's interesting. Here you have some closing works to summarize this example that you can give them a read. Yeah, but I think that this is a good introduction for the to get a basic idea of how this Bayesian decision theory works. Yeah, which is one of the most fundamental principles in decision making in AI. Okay. Yeah, and again, let me remind you that if you want to learn more and dive more into this, which there are many, many more things to learn, super interesting, you have a link, direct link here to the AI Foundations for Robotics course, where you are going to go much deeper into decision theory, but also into many, many other things and other foundational knowledge for AI, for robotics. All right, so let me have a quick look here at the chat. Shouldn't power be its own state? Shouldn't power be its own state? I don't get this question, Ahmad. So the states are related to the room states. Yeah. So basically, that's two states. The room can be either clean or dirty. Yeah. Hello, Salvatore. Hello there. Thank you very much. Thanks. No worries. Alan is asking, what projects that relate AI and robotics have you seen that got your attention? Well, many. There are many. Well, now the one that comes to mind is the Optimus robots from Tesla, right? That there was this super cool demo a few days ago from Tesla with the Optimus robots. That was impressive. Okay, I have doubts if it's fully AI. Actually, I know that it's not fully AI. There are some tricks there, but yeah. So AI is growing very quickly. That is a fact. Yeah. So yeah, I think it's a great time to start learning about AI and to get into this wave. Yeah, because it's unstoppable. It's unstoppable. As in, you have a state vector, CP, where C is cleanliness and P is power level. Okay, I'm not sure I understand your point, Ahmad. In any case, you can try yourself. Okay, so now you have this project. Okay, this is yours for try. So I encourage you to test. Okay, try changing the values in the loss matrix. Try creating different loss matrix. You can also play in this example to change the states for other things, etc. Yeah. So with this code, try, experiment, and learn with it. Yeah, this is why I am sharing this project with all of you, so that you can play and experiment with it. All right? Then I'm going to leave the class here. Thanks again, everybody, for attending to today's class. I hope that you enjoyed it. I hope that you have learned something from it and that you can take something from it. And yeah, I'm going to see you in the next class. For the next class, we are going to prepare something special because it's going to be open class number 200. I don't know yet what it's going to see, but we will let you know in the following days what we are going to be preparing for the 200th open class. So yeah, as always, until then, take care and keep pushing your robotics learning. Bye bye.